pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute, BPM, and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both sets of data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rates between smokers and non-smokers? How big? Well, as with everything when we're doing our hypothesis test, the first thing we have to do is identify the parameters. Here we're comparing two means. So the first one is mu sub s is going to equal the average pulse rate of a smoker, and mu sub ns is going to be the average pulse rate of the non-smoker. So I want to make sure I have my subscripts there so that way I can keep the two mu's separate and know which one represents which. After I've identified the parameters, I can now write my hypotheses. So my null hypothesis is that the mean of the smokers is equal to the mean of the non-smokers, or I can rewrite it as mu sub s minus mu sub ns equals 0. And my alternative hypothesis is that there's a difference. So mu sub s is not equal to mu sub ns, or bring it over, I have mu sub s minus mu sub ns does not equal 0. So here's my hypotheses to find out if there's a difference between the average pulse rates of smokers versus non-smokers. Well, now I have to check my assumptions and conditions. Randomization condition, it was stated in the problem that the subjects were randomly chosen for the groups that they were going into. Independent group assumptions, well, the two groups should be independent of each other since they were chosen at random. 10% condition, each group is less than 10% of the population of smokers and non-smokers. So when I do 10%, I'm going to do 10% condition on each one. Nearly normal condition. Well, here it was stated that both sets were roughly symmetric and had no outliers. So now that I've checked it, that means my conditions are met and I can perform a two-sample t-test. So now I'm going to identify the key information. And notice, I do write my subscript for each one. So the sample size for the smokers is 26. The mean for smokers is 80, with the standard deviation for smokers at 5. The sample size for non-smokers was 32, with a mean of 74 and a standard deviation of 6. And degrees of freedom. Well, here we're going to approximate the degrees of freedom. And the way we do that is take the sample size of the smokers and the sample size for the non-smokers, add them together, and then subtract 2. So in this case, it's going to be approximately 56. Now, I'm going to find my t-score, and this is the formula I'm going to use. The mean of the smokers minus the mean of the non-smokers. These are the means from the sample, minus my mu, divided by the square root of the standard deviation squared over the sample size of the smokers, plus the standard deviation squared over the sample size of the non-smokers. So when I plug my numbers in, notice mu sub s minus mu sub ns is 0. That's based off the hypothesis that I had for HO and HA. Notice when I brought them over, it said equal to 0. So this is always going to end up being 0 for what we're doing. And then here's my average. And when I calculate it, I get a t-score of approximately 4.15. Next thing is to find my p-value. Now here it's a two-tailed test. So when I write my notation, it's going to be 2 times the probability of t sub 56, t in degrees of freedom of 56, is greater than 4.15. And the reason why I use greater than is because my t-score was positive. If it was negative, this would be a less than sign, but it's positive, so it's greater than. And when I solve that, I find that I get 0.0001. Now, as far as finding the p-value is concerned, and also degrees of freedom, I will be doing another video so you can see how it's done using the calculator. Now I can write my conclusion. At a significance level of alpha equals 0.05, we reject HO because the p-value is small. Therefore, there is enough evidence to say there is a difference in the average pulse rates between smokers and non-smokers. So here we finished our hypothesis test and came to our conclusion. Well, now we have to answer the second question. And to do that, we're going to create a confidence interval. So here we have the mean difference, so the difference between the average smoker minus the average of the non-smokers, plus or minus t star of 56 times the standard error. When I plug everything in, okay, what I get is 3.1 and 8.89. This section here, again, I'll show in a separate one with how I did it with a calculator. Once I've created my confidence interval, I can now do my interpretation and conclusion. I am 95% confident that the average pulse rate for smokers is approximately between 3.1 and 8.9 beats per minute higher than for non-smokers. So that's how I would interpret my confidence interval. And once I've done that, I've got my conclusion and I'm done. If you have any questions, please be sure to ask.